So we have this differential equation here, and given that x is equal to 1 and y is equal to 4, we need to find the particular solution to this differential equation and give an answer in the form of y is equal to f of x. So how do we go about solving this type of question? So first things first, what we need to do is we need to bring all of our y terms on one side and all of our x terms on the other. So what does that look like? Well, we would get 1 over a minus 3 y minus 2 dy, and that is equal to a 1 over a 2x plus 1 and then an x plus 2 dx, okay? And once we're at this stage, well, we have dy over dx. We want it in the form of y equals f of x. So how can we get y? Well, that means that what we need to do is we need to integrate both sides, okay? So we just need to integrate both sides now. So one thing we've got to think of is right now we have that 1 over 2x plus 1 x plus 2. Now we cannot integrate that right now. We need to split that into partial fractions first. So let's do partial fractions on the 1 over 2x plus 1 x plus 2. So if we do partial fractions on that, then that would be a over 2x plus 1 plus b over x plus 2, and that would equal 1 over the 2x plus 1 x plus 2. So therefore we would get a times x plus 2 plus b times 2x plus 1, and that would just equal 1. And now at this stage, if we let x be minus 2, then that will cancel out the a, and we're left with a minus 3b is equal to 1. So we know b is equal to minus 1 over 3. And then for that b, if we make the x minus a half, therefore we would get a times minus a half plus 2, which is just 3 over 2. So we get a 3 over 2a, and that would equal 1. So we know a is 2 over 3. So now, as you can see, what I've done is I've split up that fraction into partial fractions. So now we have 2 over 3 times 2x plus 1 and then minus 1 over 3 x plus 2. And now we have it in a form where we can integrate. So what I'm going to do now is before I integrate, I'm going to take out the factor of minus 1 over 3 just to make it easier. I'm going to put it outside. So we get minus 1 over 3 and then the interval of 1 over y minus 2 dy. And on the right side, we're going to do the same thing. We're going to take out a factor of 1 over 3. And then that will just give us a 2 over 2x plus 1 minus a 1 over x plus 2. You don't need to do this, but I just find it makes it a bit easier, okay, with respect to x. And now if we integrate this, what do we get? We get a minus 1 over 3, and then that will just be a ln y minus 2. And that is equal to 1 over 3. If we integrate that, we will just end up with a ln of 2x plus 1, okay? And then for this one, we would get a minus ln x plus 2, okay? And then also these questions, don't forget that you're going to need a plus c as well, because there will be a constant, so you just put plus c. You can put it on any side you want to. It's up to you where you put it. Okay, now what I'm going to do is I'm going to divide by a minus 1 over 3 to get rid of the 1 over 3 because we don't need it anymore. So if we do that, I get a ln y minus 2. And that is equal to, if I divide by minus, we're going to get a minus ln 2x plus 1 plus a ln x plus 2. And with our constant, well, if we have a constant and we divide it by minus 3, it's still just going to be a constant. So in that case, I'm just going to write that as b, okay? I can leave it as c, but I'm going to write it as b just so you know that we've still done something to that constant, but it's just going to be another constant, okay? So we'll have it as b for now. And now what I will do is I will just combine my lns together. So we have a ln y minus 2, and that will equal a ln x plus 2 over 2x plus 1, and that is just plus b, my constant. And now at this stage, this is where we want to take e's now. So what we're going to do is we're going to raise everything to the e, okay? If we do that, we get a e to the ln of y minus 2, and that is equal to e to the ln x plus 2, 2x plus 1 plus b, okay? And now at this stage, well, we think about this e, right? That is the same as saying e ln x plus 2, 2x plus 1 times e to the b, okay? It's the same as writing that. And again, because b is a constant, if we have e to the power of b, then that would also just be another constant. So what we can do is we can effectively let e to the power of b just equal a, which is another constant, okay? And if we do that, then what do we get? Well, we would get a e to the ln of y minus 2, okay? And then that would equal a e ln x plus 2, 2x plus 1. And then now, obviously, we can get rid of our lns, our e and lns, so therefore we're just left with a y minus 2 is equal to a x plus 2 over 2x plus 1, okay? And now at this stage, all we now need to do is we're told that when x is equal to 1, y is equal to 4, so we can use those values to work out our constant. If we do that, then what do we get? Well, if we do that, we get a 4 minus 2, so that's a 2, is equal to a 1 plus 2 is a 3, 2 times 1 plus 1 is a 3, so we get a 3 over 3, which is just a 1. So we know that a is equal to 2. Therefore, if we wish to rewrite this, it would be a y minus 2 is equal to a 2x plus 2 over 2x plus 1, and therefore our answer in the form of y equals f of x would be y is equal to 2 plus 2 of x plus 2, 2x plus 1, okay? And that would be our answer. So for this question, we have y minus x squared dy over dx equal to xy plus y. And then with the boundary condition of y equals 6 and x equals 0.5, we need to give the answer in the form of y equals f of x. So again, with this question, what we want to do is we want to get all our x terms on one side of our y terms on the other. Right now, though, we have a combined terms, x, y. So how can we get rid of that? Well, all we need to do is just factorize, okay? So we have a 1 minus x squared dy over dx. And if we factorize the xy plus y, we get a y x plus 1. And now let's just bring our x terms to the right and our y terms to the left. So if we do that, we would get a 1 over y dy, and that would equal a x plus 1 over 1 minus x squared, and then that would be a dx, okay? And now, because we know we want it in the form y equals f of x, we have dy's and dx we need to integrate, okay? Now, the first thing you're looking at is we have the x plus 1 over 1 minus x squared. So you may think you need to do maybe integration by substitution, or you may think that you may need to split into partial fractions. But really, if we was to look at this, if we was just to try and see what we can do with the 1 minus x squared, well, that is a difference of two squares, right? So we can rewrite this as x plus 1 over a 1 plus x, 1 minus x, right? So at this stage, yeah, you may think you may do some type of partial fractions, okay? Because you've got it in this form. And yes, what you can do actually partial fractions, and it will give you the right answer. Actually, if I was to just rewrite this as maybe x plus 1, and then x plus 1, 1 minus x, I guess now it's probably a bit more clearer that these two just cancel out, and you're just left with 1 over 1 minus x, okay? So you don't need to do any type of real partial fractions or any crazy integration. it actually just simplifies down to 1 over 1 minus x, okay? So now that we know that, we can put 1 over 1 minus x into that question. So I'm going to rewrite this now as 1 over y dy is equal to the integral of 1 over 1 minus x dx. And now we need to integrate these two. And if we do that, what do we get? We would get a ln y, and that would equal a minus ln of 1 minus x, okay? And then don't forget plus c. Again, you can put your plus c wherever, your constant wherever, it's up to you. And now what we can do now is we're going to have a ln y. I'm going to bring that power, I'm going to move that power to the front, so we get a ln of 1 minus x to the minus 1 plus c. Okay, and now what that means that ln y is equal to a ln of 1 over 1 minus x plus c. Now I'm going to do e's. So if I do e's again, then we do e to the ln y. That is equal to e to the ln of 1 over 1 minus x plus c. And like in our previous question, if you have something like this, then we can let e to the power of c, that will equal a. Okay, and therefore what we're left with y is equal to a 1 over 1 minus x, okay? Because the e to the power of ln will just cancel out to 1 over 1 minus x, and that e to the power of c is just equal to a. There will be times together. So you're left with y is equal to a over 1, a times 1 over 1 minus x. Now at this stage, we're told that y is equal to 6 and x is equal to 0.5. So we put those conditions in. So we get 6 is equal to a, and that is times by 1 over 1 minus a half. Okay, and we know that that will be 6 is equal to a, which is 1 over a half. So that is just 6 is equal to 2a. So therefore a is equal to 3. So therefore in our question, we know that y is equal to 3, 1 over 1 minus x. Therefore, if we just put this all together, we know that y is equal to 3, oh, wrong thing. Y is equal to 3 over 1 minus x. We'll do one last question. We will do, we need to solve the differential equation of dy over dx equal to xy sine x when y is equal to 1 and x is equal to pi over 2. For this question, again, we want to group our x terms on one side, our y terms on the other. If we do that for this question, we will get a 1 over y dy is equal to an x sine x dx. And again, we want to solve the differential equation, so we want to get something in the form of, we want y, okay, we want y by itself, or just y. We want some type of expression for y. So in this case, again, we need to integrate. So, and if we do that, well, let's start with the x sine x, because if you've seen maybe my other video on integration by parts, that is exactly what we need to do for this type of question. This is an integration by parts example. So if we go solve this by integration by parts, then how do we do that? Well, what do we get? Well, we get this. We can make u is equal to x, okay, and we can make dv over dx, that can equal a sine x. So then du over dx is equal to 1, and v would equal a minus cos x, okay? We need to integrate that sine x. And now if we do the formula of integration by parts, the formula of integration by parts is uv minus the interval of v du over dx, okay? That is the formula of integration by parts, so that's exactly what we're going to do now. So if we do that now on the information we've got, we would get u times v is a minus x cos x, okay, minus the interval of v times du over dx. In our case, that's just a minus cos x. Now, a minus times a minus cos x, that will just give us a positive, so we can actually put a positive outside cos x, and then we need to integrate that with respect to x. And if we work that out, that would give us a minus x cos x plus a sine x, and then yeah, that would be it. So integrating x sine x gives us a minus x cos x plus sine x. So now that we know that the integral of x sine x is minus x cos x plus sine x, well, if we were to solve both of these now, we would get a ln y, and that would equal the minus x cos x plus sine x, and then again we need to add the plus c. And now we're told that when y is equal to 1 and x equal to pi over 2, so therefore it'll be ln 1 is equal to a minus pi over 2 cos pi over 2 plus a sine pi over 2 plus c. Now ln 1 is just 0, so we get a 0 here. Then we get a minus pi over 2 times a cos pi over 2, same as cos 90, which is 0. A sine pi over 2 is same as sine 90, which is a 1, and then plus the c. So therefore, if we work out c, we would just get a minus 1. And therefore, we're actually pretty much done. Now that therefore, you can say that the equation to this is just ln y is equal to a minus x cos x plus sine x minus 1. And that would be the equation for it, okay? It doesn't ask us to give it in the form of y equals f of x. It just wants us to solve this differential equation. We have shown that we have solved it, okay? This would be the answer. And that will be it for this video. In our next lesson, we'll be going over modeling with differential equations. And also, if you want to go a bit over maybe integration by parts, maybe you didn't maybe quite understand that, then feel free to watch my other video on integration by parts. I'll leave a link right now for you if you want to check that out. But yeah, I hope you enjoyed this video, and I'll see you on the next.